Hey guys, so I did tell you that I was not going to be here on Monday, so I'm just going to jump right into what you need to do. Please get your notebooks out, open to a nice new piece of paper. This is like two things. This is a little bit of review of some square root stuff that does relate to our CMAS test that starts this week, but this is also going to help us for after CMAS when we move into our new chapter, which is chapter 9. So we are going to take notes when CMAS is over. So, in a week, a week from today, I will review this lesson again. And then I will assign homework. So all I really want you to do is follow along with the video, copy down the notes and problems, not listen to the announcements.
Really quick, teachers, there was an issue in Q, so we need you to refresh.
Okay, now the announcements are over. Please get out your notebook. Again, we're going to copy down the notes, and then that'll be it. I will be back tomorrow, and I know tomorrow is CMAS, and I will not see you. So just do your best for those of you who are going to be taking it. If you have opted out, you can still check our Schoology page for the opt-out assignments. True for remote students as well, in case you need some math work to do. Let's just get started. So, title of the piece of paper, Lesson 6.1, Properties of Square Roots. Now, for some of you, this might not be new. I don't know what your 7th grade teacher did with square roots, so you may have seen this, you may have not, especially since last year we went out of school at spring break, so we'll see. Our learning objective is we're going to learn how to simplify and estimate square roots, because for the rest of the school year and beyond this, it is an expectation that you're able to simplify a square root. That does not always mean getting a whole number. That does not also mean having a decimal, using a calculator. It is okay to have square roots in our answers as long as they are as simplified as possible, and that's really what we're going to focus on today. The two properties that we're going to use, I need you to copy down. They don't really have a name to it. The first one says the square root of xy. Now, this is a product. Remember, when two things are right next to each other and there is no operation, assume it's a multiplication symbol. So this is saying that the square root of x times y can be broken down or equal to the square root of x times the square root of y. So I can break up a product into two separate square roots. Usually the number inside your square root house isn't already a product, so that means that there's going to be some extra steps to do before you can even apply this property. The second property is when you have a square root of a fraction, and what you can do is take the square root of the top number over the square root of the bottom, and it usually works out pretty well that at least one of the numbers, whether it's the numerator or the denominator, does come out to be a perfect square. Sorry about that, guys. I'm getting a lot of interruptions today. Let's go on. So the next little chunk. Oh, I should mention that if you need to pause the video, pause the video. If you need to copy things down or if I'm going too fast. This is our next chunk. These are the actual steps that we're going to follow to simplify square roots. So step 1 says list out all the factors of the number inside the square root. Step 2. Look for the ideal pair. Well, what does that mean? An ideal pair, and this is just my phrasing, trying to simplify things, it's when you have one factor that is a prime number and the other is a perfect square. Now let's review some of that vocabulary. A prime number is when the only numbers that multiply to, whatever number you have is 1 in itself. So to give you an idea, 3 is a prime number because the only whole numbers that multiply to 3 are 1 and 3. Another example could be 5. The only numbers that are whole numbers that multiply to 5 are 1 and 5. You might be able to start spouting out some others like 7, 13, 11. There's so many, but those are just a few. a perfect square. We did a little bit of square root stuff last week in our CMAS review. It's going to come back again. But a perfect square is when you have a square root house. There's a number inside your square root house. And you can actually find a pair of numbers that multiply to whatever's inside the square root house that's the same. It's also in the square root cheat sheet that hopefully the sub has passed out to you. If they have not at this time, please pause the video, raise your hand, and ask the sub to pass out the square root cheat sheet. An example of perfect squares could be the square root of 4. When I think about numbers that multiply to 4, I would have 1 and 4 and 2 and 2. Because I have a pair that's the exact same number, 2 and 2, this is called a perfect square. So we're looking for really things that are on our cheat sheet or that have this pattern to it. Going back to our step 2, it says after the first line, it says if you cannot find an ideal pair, look for the factor pair with the largest perfect square. That's our second best option. Sometimes you don't have an ideal pair of factors and it's fine. So you're just looking for when you have a really big perfect square. And step 3, we are going to rewrite the number inside the square root as a product and simplify the expression using the properties you just wrote above. Now it kind of sounds weird and hard and it's fine eventually. You'll get used to it. We're going to do it so much in chapter 9, which is the next chapter we'll move into after CMAS, that by the end of the chapter, this won't feel as hard as it might feel right now. So let's just go with it. Let's go example 1. We're going to use the 3 steps above to simplify the square root of 150. Now I'm going to tell you right now, the square root of 150 is not a perfect square. So what we have to do is use those steps above and use our square root cheat sheet as well to figure out how to rewrite this. So the first thing I'm going to do, I'm going to scroll back up for a moment. I'm going to follow step 1 that says list out all of the factors of the number inside your square root house. So inside my square root house, I have the number 150. So then we're going to start thinking about all of the numbers or all the possible pairs of numbers that give me 150. This is also where that divisibility rule sheet that is stapled to your square root cheat sheet comes in handy. So if you're like, I don't know how to list out all the factors. Well, divisibility rules help you figure out what number can go into what. So if you even just look at your divisibility rules, you can start going down the list, starting with 2. If a number's ending in 0, you can divide by 2. So I know automatically there's the original pair 1 and 150. Then we go to 2, because I know I can divide a number by 2 if it ends in 0, and that would be 75. Now we're trying to think, can it be divisible by 3? And if you're not sure, read the statement on your divisibility rule. See if you can apply it. See if it works, and then actually divide. So when you do that, you'd end up getting 3 and 50. And we keep going. If you look down your divisibility rules, 4, it does not meet the criteria for being divisible by 4. So then you move, can I divide by 5? And if a number ends in 0, well, yes, you can divide by 5. And so you'd have 5 and 30. Gotta scroll down because I know there's more coming and I need more space. Keep on going. It does meet the rules of 6. So I know 6 can be divided. And when you divide 150 by 6, you'd have 25. I can keep going. Let's see, I know 10 can go in. I know it does not meet the requirements of being divisible by 7. I know it does not meet the requirements of being divisible by 8 or 9. But 10 for sure can go in. And it can go in 15 times. And that is it. So, this is the full list of factors. Now, I do recommend that when you do your own eventually, that you use a calculator. It's probably easier just to use a calculator on your computer, because I am not going to have the graphing calculators pulled out because I'm obviously not there and I cannot monitor or clean them after. So just use the calculators on your computer, use the Google calculator. So step 1's done. I've listed out all of the factors of 150. Step 2 says now let's look for an ideal pair. An ideal pair is when one number is prime and the other is a perfect square. So what I'm going to do is just look. I'm going to look down the list to see where do I have perfect squares. So 1, it doesn't really work for me. I know it is a perfect square, but it's not good enough. I'm trying to compare each factor to see, do I have one number that's a perfect square and one number is prime. So let's see, going down, 2. 2 is prime. Let's look at its other factor, 75. That is not a perfect square, so let me move on. 3 is prime. Let's look at its factor pair, which is 50. 50 is not a perfect square. Let me move on. I see 5. 5 is a prime number. Let's look at its factor, and it's a 30. Well, that's not a perfect square, so let me keep going. I see 6. Well, 6 isn't prime, but that's okay. We can still kind of keep in mind. Let's look at its factor pair. Its factor pair is 25. What I know is that 25 is a perfect square. It's on my cheat sheet. So far, I have one factor pair that might work because I have a perfect square. My last pair of numbers are 10 and 15. Neither of them are prime and neither of them are perfect squares. So the factor pair 6 and 25, this is actually not an ideal pair. The reason is because 6 is not prime. But that's okay. We can look back up that last little bit that says, if you cannot find an ideal pair, look for a factor pair with the largest perfect square. Now in our case, it's the only factor pair that's a perfect square, so that's fine. What we're going to do after identifying these two numbers is I'm going to rewrite the square root of 50, so I just write it as these two numbers, 6 and 25, being multiplied together. So I'm still going to have a square root house. Please let your perfect square go first. So I'm going to just rewrite 150 as 25 times 6. And if I worked backwards and I actually multiplied it, we'd have 150. So I'd be back to where I started. Now I can use the rest of step 3 because I rewrote my number inside the square root as a product. I'm going to simplify it using that very first property. In this case, I can say that this gets broken up into 2 square roots. The square root of 25 times the square root of 6. I end up going from 2 square root houses to 1. Or sorry, 1 square root house, to 2. Misspoke. From here, we can keep simplifying. The square root of 25 is on our cheat sheet, and we can actually evaluate that. That's 5. Times the square root of 6. Well, the square root of 6 is not on my cheat sheet, for 1, so I'm just going to carry it down. This is actually our final answer, is 5 times the square root of 6. It can also look like 5 right next to the square root of 6, and it's the same thing. So just kind of take a look at both of them are perfect ways to answer it. The reason I know I'm done is because if I listed out the factors of 6, all I would have is 1 and 6 and 2 and 3. And none of those numbers are perfect squares, so I know I'm done. And this is as simplified as possible. Our answer will still have a square root. Let's try B. B is a little bit easier. So, well, way easier. B, I see we have a square root fraction. We have a square root of a fraction. So I can't do much yet with a square root of fractions. What I could try to do is simplify the fraction inside the square root house. And looking at this, I know I can't. So I cannot simplify the fraction inside. I'm just going to go straight to applying my properties, which I'm going to break this up to be the square root of the top number, so square root of 15, over the square root of the bottom number, 64. And I'm going to try to keep simplifying from here. Well, I know the square root of 64, I know that's on my cheat sheet, and that's just an 8. And then I have the square root of 15. Well, if you have a square root in your answer, you need to be 100% sure to simplify it as possible. The way you do that is you list out the factors of the number inside. So I'm going to list out the factors of 15. That would be 1 and 15 and 3 and 5. None of those are perfect squares, which means I am done. And this is as simplified as I can possibly get. I do have two I want you to try. Please try to simplify C and D. Please pause the video now, try your work, and when you're ready, unpause to check your answers. Okay, let's see how this went. So the square root of 28. Well, I have a square root of just the number. So let me start with listing out my factors. And I'll kind of show that below here. So the factors of 28 include 1 and 28, 2 and 14, and 4 and 7. So looking at the numbers, I am going to try to find an ideal pair. An ideal pair is when you have a prime number and a perfect square. So looking at the first pair, I have 1 and 28. Well, that never gets me anywhere. It's the same exact factors. Neither of them are perfect square. Well, 1 doesn't really count as perfect square. It is true, but anything times 1 is always 1, and it doesn't really do much for you. So let me just kind of pretend like it's not there, and I'm going to look at the other factors. 2 and 14. Well, 2 is prime, so that's good. And 14. Ooh, well, 14 is not a perfect square, so I can't even deal with this factor pair. So I look at my last one, which is 4 and 7. Well, 4 is a perfect square. That's really good. And 7 is prime. So this is actually an example of an ideal pair. That's really nice. So what this means is that you should have broken up the square root of 28 to equal the square root of 4 times 7. Now you're going to let the perfect square go first. I'm going to say 4 times 7. Applying the properties from the beginning part of our lesson, we have the square root of 4 times the square root of 7. Using your square root cheat sheet, square root of 4 is 2 times the square root of 7. This is actually as simplified as it possibly can be. So it's 2 times the square root of 7, or you can write it as just 2 right next to the square root of 7, and it means the same thing. This is the reason why we have an ideal pair is because if you find that one factor is prime, then when you break it up into these square roots, there's absolutely no way it can be broken down. So it just gets all the simplifying out immediately. Hopefully that went okay. If not, we have plenty more to practice on. Let's go to D. Well, D, you should have tried to look inside the square root house and see if you can simplify the fraction, and you can't. So then you immediately go to the properties from the beginning of the lesson, which says take the square root of the top number over the square root of the bottom. Well, I know the square root of 100 is definitely on my cheat sheet. That's 10. And the square root of 11 is actually not on my cheat sheet. I know it does not work. And I know 11 is prime. So that means there's no way I could possibly break up the square root to be smaller than it is. So that's your final answer. Square root of 11 over 10. Let's keep going. Let's talk about evaluating a square root and simplifying. So this is, again, this part is going to lead us into chapter 9 because I wrote something that we're going to see again. So evaluating a square root, evaluating means solve or do as much math as possible. An example 2, I kind of put the directions in there, and it says use the given values to evaluate and simplify the expression. So for A and B, there's only an A and a B, we're going to use the same expression, which is the square root of B squared minus 4AC. We are going to see this expression again in chapter 9 plus some, but we're going to use this to plug in the numbers they gave us for the A, the B, and the C. We're going to do all the math we can, and then we're going to try to simplify it like we did in example 1. I need a little more space. So let me just start plugging in numbers. Where I see an A, I'll plug in 2. Where I see B, I'll plug in -8. Where I see C, I'll plug in 4. So square root of B squared. Well, that would be -8. I'm going to put that in parentheses, squared, minus 4AC. That means 4 times A times C. So minus 4 times A, which is 2, times c, which is 4. From here, it's order of operations, starting with your exponents, then multiplication, and then subtraction. So negative 8 squared, well, that's negative 8 times negative 8, which is positive 64. And then we have, I like to treat this minus 4 as like a negative 4. I find it to make things easier. So if I treat this like a negative 4, then I'm just going to say negative 4 times 2 times positive 4. And that gives me negative 32. I just find it easier to think of it like negative when I do my math. Kind of saves me some time. From here, I just do my subtraction. So 64 minus 32 is 32. So right now I have the square root of 32. You are not done until you check the factors of 32. So let's make some space. Come on. Make some space. My computer's not having it. Space, bud. And scoot over. So what we're going to do is list out all of the factors of 32 and then try to find an ideal pair if possible. It's not always, but it's okay. So we have factors of 32. Obviously, you start with 1 and 32. Use your divisibility rules to help you narrow down what numbers can be divided and what numbers cannot be. This is an even number, so I know 2 can go in. So you divide 32 in half, and that is 16. 3 does not work, so then I try to move on to 4. 4 does go into 32 8 times. I know this is not divisible by 5. Let's see, not divisible by 6. Let's see, it is divisible by 8, which then repeats us. So we are, back to where we need to be, which is good. Now we're looking for an ideal pair. So let's look at our numbers. 1 and 32 never get you anywhere. Pretend like it's not there. 2 and 16. Well, 2 is prime. 16 is a perfect square. Ooh, so that's actually an ideal pair. Let me circle it. Let's rule out anything else though, just to be sure. Because, I see 4 and 8. Well, 4 is a perfect square, but 8 is not prime. So even though I have a perfect square, it doesn't always mean, I have actually 2 factors that have a perfect square, 16 and 4. So you're trying to see, out of those, do you have an ideal pair? And we do, because one number is prime, one number is a perfect square. You really want that combination. If we didn't have that, then I would select 4 and 8. But I have an ideal pair, so I'm going to go with it. My ideal pair gets rewritten inside my square root house. Perfect square goes first, so I say 16 times 2. Applying our properties, I'd have the square root of 16 times the square root of 2. Square root of 16 using our cheat sheet is 4 times the square root of 2, and that is it. So our final answer of plugging in these numbers and simplifying is actually 4 times the square root of 2. Try yours. I need some space because I know I'm going to have to go through this problem again. Please pause the video, and I want you to plug in these numbers into the expression b squared minus 4ac. Unpause when you're ready to check your answers. Okay, let's see how it went. When you plugged in these numbers, you're plugging in each variable for its appropriate spot. So b squared is actually 4 squared. I'm not putting this in parentheses because b is not negative, so it just works out nice. So we have b squared minus 4 times a, which is 3, times c, which is negative 2. Going through order of operations, we'd have 16, because 4 squared is 4 times 4, not 4 times 2. And then you do, and I'm going to treat this as negative 4 times 3 times negative 2, which is a positive, so I'm going to put a plus, 24. Well, I'll just add those together. 16 and 24 is 40. So now I have the square root of 40. We are not ready to say we're done until you have tried to simplify the square root. Well, you need to list out factors of the number inside to make sure it is simplified. So I have factors of 40. You have 1 and 40, 2 and 20, 4 and 10, and that's it. So looking through our numbers here. We're hopefully trying to find an ideal pair. If it doesn't happen, it doesn't happen. First pair is 1 and 40. Never get you anywhere. I'm just going to cross it off. The next pair, 2 and 20. Well, I know 2 is prime, so that's helpful. But 20 is not a perfect square. So this pair does not work for me. My last option is 4 and 10. Well, 4 is a perfect square, which is really good. 10 is not prime. So that just means we don't have an ideal pair, and that's okay. We kind of have like a semi-ideal pair. So this means I'm going to rewrite the square root of 40 as a product of these two numbers. So I'm going to let the perfect square go first, which is 4 times 10. Applying our properties, I'd have the square root of 4 times the square root of 10. Square root of 4, according to our cheat sheet, is 2 times the square root of 10. Now, to be 100% sure you are done simplifying, check all of the factors of now 10, which are 1 and 10 and 2 and 5. Out of these, there is no number that is a perfect square, so we are done. There's nothing more I can simplify. Hopefully that worked out. But if not, remember in a week I'll review this again. Let's go into our last part. It's example 3. We're going to simplify what's called a radical expression. Radical is another way we talk about square roots, eventually cube roots, fourth roots, nth roots. Nth just means I could pick any other number and put it in. It just means you have some kind of square root house of some kind in the problem. So this kind of expression that you see on A or 3A comes again when we learn about the quadratic formula in chapter 9. So when you see something like this, where on the top part of a fraction you have a number, and it could be plus or minus the square root all over one number, well, we have to try to simplify this, and the way we do this is to rewrite this into 2 fractions, and then we try to simplify. So the way I would do this is I would take the top number, the very first number I see reading left to right on the top part of my fraction, which is 6, and I put it over technically a common denominator of 2. So I'd have 6 over 2. Then I would take the second term, which is a square root house, and I'd also put it as a fraction over 2. So then I'd say plus square root of 8 over 2. And from here, I'm going to try to simplify the normal numbers, the like terms. Now, the only like terms I have are actually just the constant 6 over 2, and that simplifies to be a nice whole number of 3. Plus, a lot of you might immediately say, hey, I think this is the square root of 4, which means it's 2, so my answer is 5, and you're wrong. So why are you wrong? You're wrong because the square root of 8 and the denominator of 2 are not like terms. They are not both square root houses. Only one is a square root house. So it's like saying I have an apple divided by an orange, and that makes banana. And that's not true. So you can't divide it like you might really want to. Resist that urge because they are not like terms. Well, if they're not like terms, then you're probably like, Ms. Horner, what do I do? Well, that's a good question. Well, the only thing we can do is try to simplify the square root. So I'm going to list out the factors of 8 and see what I can do with that. Factors of an 8 include 1 and 8 and 2 and 4. Cool. Well, let's look. Are any of those perfect squares, or better yet, an ideal pair? 1 and 8 get you nowhere. And then it only leaves me one option, which is 2 and 4. Well, 2 is prime, yay, and 4 is a perfect square. This means it's an ideal pair. So I can rewrite the square root of 8, and I'm kind of just going to show that work off to the side. I can say the square root of 8 is the product of these two numbers, so I can say square root of 4 times 2, which is the square root of 4 times the square root of 2 in 2 separate houses. Using our cheat sheet, square root of 4 is 2. So I say 2 times the square root of 2. What I'm going to do is substitute the expression square root of 8 with our simplified expression 2 times the square root of 2. Well, what does that look like? The 3 carries down, so I still have 3, plus carries down. I still have a fraction bottom of 2, but instead of 8, square root of 8, I write our simplified answer 2 times square root of 2. Well, by doing this, I actually have like terms now. I have normal numbers right here. 2 divided by 2. Well, you might be like, well, I don't understand why I can just divide it now, but I couldn't before. And it'd be a great question. I can rewrite these fractions so that I have a fraction times like it's not a whole number, but the square root. So I could rewrite this as 2 over 2 times separately the square root of 2 over 1. I can pull it apart even more, which is why I know immediately I could divide these two, because I broke it up so that my like terms are together. And 2 divided by 2 is 1. So I really have 3 plus 1 times square root of 2 over 1. Square root of 2 over 1 is just square root of 2. And so square root of 2 times 1 is square root of 2. So this gives me a final expression of 3 plus square root of 2. We took this ugly fraction and we simplified it down to something that looks a little nicer, though you might be like, I hate this. And this is only a preview. We're going to end up doing this kind of simplifying a lot. We'll spend an entire day on it, in fact. So don't feel overwhelmed yet. I'm just trying to show you some stuff that's coming up. And we're going to do one more. Now, I don't know how you feel about you starting it yet, but I'll give it a shot. I want you to pause this video, try this problem, just see how far you can get before you get stuck, and then unpause and just check your work and copy down what you need. So let's see how it goes. From here, I am going to split this up into 2 fractions. I'm going to take 18, put it over the denominator of 6, plus square root of 72 over the square root of 6. From here, you want to try to simplify the normal numbers, which is actually the fraction 18 over 6. And that's really nice because it simplifies to a nice whole number. And we get 3 plus square root of 72 over 6. Square root of 72 and 6 are not like terms. So do not divide this. Instead, list out the factors of 72. So let me scroll over here. Factors of 72. Now this is going to be a longer list. So we have 1 and 72. And then you can go down. This is an even number. Use your divisibility rules. This can be divided by 2, which is 36. It can also be divided by 3, which is 24. It can also be divided by 4, which is 18. It cannot be divided by 5, but it can be divided by 6. I'm going to keep on going. It cannot be divided by 7, but it can be divided by 8, which is 9. And that is actually it. So those are all the pairs of 72. From here, we start looking at our factors and try to find an ideal pair. So 1 and 72 will never work. 2 and 36. This works because 2 is prime and 36 is a perfect square. So this is an ideal pair. But let's rule out everything else just to make sure we're clear. 3 and 24. 3 is prime, but 24 is not a perfect square. It's out. Now we have 4 and 18. Well, 4 is a perfect square, but 18 is not prime. And I already have something I know will work, so I'm just going to rule out that one. 6 and 12, well, neither of them are perfect squares. I'm not even going to give it any more time than that. And 8 and 9. Well, 9 is a perfect square, but 8 is not prime, and I have a factor that's ideal, so I'm just going to rule it out. So this means I can rewrite square root of 72 as a product of these two. So let me show that off to the side. Let me do a little squiggly wiggle. Squiggly wiggle. Square root of 72 can be broken up to be the square root of perfect square, 36, times prime, 2, which can also be broken up into square root of 36 times separate square root house of 2. Using your cheat sheet, square root of 36 is 6 times the square root of 2. Because this is an ideal pair, I know I'm done simplifying. So what I'm going to do is in my expression with the fraction and the 3 over here, I'm going to substitute the actual square root house of 72 with our simplified expression. What this gives me is 3 plus, because that carries down, a fraction of 6. And then our 6 over the square root of 2 goes on the top. 6 times, not plus. From here, I have like terms, which are just now the constant 6 over 6, which simplify out or cancel out to be 1. So it's really 3 plus the square root of 2. Isn't that funny that it's the same exact answer? That's just a coincidence. All right, that is it. So if there's still time left in class, do whatever you want. Just don't be loud. I will see you guys tomorrow. Good luck on CMAS. Bye.